Hi, this is Unit Codes. I'm Karnveer. Let's get started. So I've segmented this video into two parts rather than keeping it one long one, and also if I made this tutorial a complete comprehensive one, it would have exceeded like more than 1 hour of duration. So I didn't want to keep it that long. I've cut a lot and I've sped up some processes. So this is more like a process than a complete comprehensive tutorial. Do let me know though what you think, if you want a complete comprehensive video or this is better. Enjoy. First we create a new Unity project and I'll name it whatever I want in 3D. Now we need a character model that we're going to use as a protagonist. There are two ways to do it. Either we create our own custom model in Maya or Blender or any 3D modeling software, but we're in the learning space. I'm just going to use a pre-made asset, and looking for it online I found this wonderful model that is coherent with our PUBG characters. So this model is provided by Final Render Animation Studio. Thank you. Now we download and import the player and drag and drop provided textures that came along with it. Okay, there are two major ways that we can control our character. The one is rigid body method and the other is character controller method. Character controller method is the one that we'll be using here because it will give us more flexibility. Also, we would have to code a little bit more, but we're here to learn, so there's nothing to worry about that. And it will be much more flexible over using rigid body. So let's move on. We add a character controller component and adjust its center and height according to our model so that it covers our player's body. Usually we would add a collider to our model, but in this case, since we're using a character controller component, we don't need to add an extra collider because the character controller component has its own predefined collider that we just actually set up. Now in our hierarchy, we need to make main camera game object child of our player and adjust our camera accordingly. Let's just cross-check the camera's position with PUBG's camera from Google. Now we create a new script named mouse controller script and we double click to open it in Visual Studio. Do note that I'm using Visual Studio Code as it's light and easy on my PC. However, you might have Visual Studio Community already on your system, and if you don't, there's nothing to worry about as it's included in the Unity installer package by default. Okay, I'm pretty sure that with this code we can pan horizontally, but we might have trouble panning vertically because the camera might act weird since it's attached to main camera that is in fact child of our player game object itself. Now I create a player controller script in the same way I created our mouse controller script, but instead we assign it to our player game object. Do note that I have not provided the footage of me typing as I believe it could make the video unexpectedly longer than required, since everything including source code will be provided to you. Moving on, we do need a more robust camera system, so let's just unchild main camera and we import this beautiful asset known as Cinemachine from the Unity Asset Store. You can use Control 9 to access it within your editor, or you can just go to your web browser and download the asset from there. Okay, so I type in Cinemachine and I import it inside my project. Then I open the Cinemachine tab and click Virtual Cam. However, after experiment for almost 3 minutes, I realized I clicked on the wrong variant of Cinemachine and I actually needed the free look module instead of Virtual Cam. Keeping things aside for camera options for now, I wanted a crosshair as it would help me in defining the center of our game view as well. Unable to find something online, I created a to-go crosshair of it in Inkscape myself. Another note, if you have the option of getting an asset online and it serves the purpose of your work, then it's a wiser decision to choose that instead of creating and reinventing the wheel yourself. Until and unless you are producing something of your own and planning to commercialize it, it's always good to use a pre-made asset that gives us permission to use ethically under the Creative Commons license or any open source one. Alright, moving on, I imported the Crosshair and I created an art folder just to keep things a bit organized, and I placed our PNG file in it. Then I changed the import setting from default texture to sprite, since we'll be using it on our canvas that we'll just be creating now. Tip: whenever planning to implement UI elements, always use the canvas, as it's much more UI friendly and easier to fiddle with than independent UI objects outside of the canvas. It's a good touch that Unity has provided us with and made our UI handling much easier. One canvas can handle multiple UI elements, so no need to create multiple canvases. To use Crosshair on our screen, we are going to create a new UI element and canvas is going to be created automatically. Adjust canvas component properties accordingly. UI scale mode must be dependent on scale with screen size instead of constant pixel size, because then the canvas won't adapt to different screens if it's kept constant and might give off weird out of screen UI results that we see on some poorly built apps too. Native resolution is gonna be 1920 by 1080 and we're going to maintain a balance between horizontal and vertical by setting the match to 0.5. Then moving on to image that's on our canvas, we centralize it and drag and drop our crosshair into our source image. Alright, now we have our crosshair in the center. Some more fiddling with our Cinemachine camera. Alright, I did tighten our camera, but it's still nowhere of what we actually want, so let's ignore our camera again for now. A wise man once said, if you can't find a solution in a while, come back with a fresh mind and you'll definitely achieve more than you did before. Now let's begin with the shooting element. Since our player is the one shooting, we just select our player and we add a new script to it. Let's name it shoot script. Let's name it ammunition script. We'll use shoot functions inside this script. You can name whatever you want though. Alright. To shoot, we need a gun, and I found this 416 Chinese ripoff version named HK416 on Sketchfab by Johnson. Thank you. And as an avid Chinese product lover and user, let's take this one. It's pretty beautiful. Then I set the gun position accordingly, and do keep in mind that we have to set it as a child of the player's hand, so that when we move our player's hands, it moves along with it too. Adjusting our Quaternions rotations. We use Quaternions mostly for rotating stuff in Unity, but that's a video of its own some other time. Back to gun. Well, now I need a point in space where I'm going to shoot my bullets out from my gun. So I create an empty game object and name it fire point. Then I place that fire point right in front of my gun where all the muzzle flash is going to take place. Fun fact. Usually for guns that have a high firing rate, people don't actually use bullets. They just emit muzzle flashes and be done with it, until and unless the game is going to take place in slow motion where the bullets are actually needed to be seen. Now as you can see, we are getting somewhere. The blue lines are actually the ones that our virtual bullet is supposed to travel through. I use debug.drawray, so that's why I can only see it in my scene view. Tip: imagine scene view as a behind the scenes screen of what is actually happening in the background, and think of game view as to what is the front end or the view that the gamer gaming the game is going to see. In layman's terms, think of it this way. Scene view is for devs and game view is for the player that's going to play your game. So why two views instead of one? Well, scene view is really helpful in displaying gizmos and debugging stuff, just like we did with our invisible bullets. Moving on. Now we need an enemy to shoot at. To keep things simple, we right click in the hierarchy and let's just create a 3D object and then cube. Let's position it somewhere ahead of us and scale it so that it's huge enough and an easy target to shoot. Let's name it enemy 2. We need to tag our enemy with an enemy tag so that we can find it in our script more easily and in an optimized manner. So let's create a tag and then tag it as enemy. If you notice that when I click my left mouse button to shoot, my enemy disappears. It's because right now I'm directly destroying my enemy with a single shoot and nothing else that my ray hits will be destroyed, because we have added an if statement to only destroy if it's tagged as enemy. Oh, and I realized we need a shooting sound as well, which we'll get to in a moment. Well, it's a good practice to child our enemies and players to an empty game object so that when we need to change our enemy or player model, we can just replace the 3D models without going through the whole process again. That's exactly what we're going to do now. Make the enemy cube a child of a parent that is the actual enemy. So if we need to replace the cube with a slender or a humanoid villain, we only have to make minimalistic efforts. It's good future-proofing practice in most cases. Then let's give our enemy some health so that it dies only after a few shots and not instantly. So we create an enemy script, or better, a generic health script, and assign that to our enemy. Okay, now I need a muzzle flash effect to show that our gun fires something. Like I previously mentioned, for higher fire rates, most of the time muzzle flashes are used instead of showing individual bullets. So I explored the internet, and to my notice, Unity's own asset store has a free particle system pack named WarFX that I think will be good enough for us to use here. After experimenting with few, I found the one named WFX MF4P Rifle 3 prefab to be suitable to use. So we place it at our fire point as its child, and then we just adjust its rotation and size in its transform component. There is a light game object that came as a child of our asset. We just disable that because we don't want that. Okay, time for some sound effects. We create a folder named audio, and in that we import our gun sound that I found on MobCup, created by the person TopCup. Oh, thank you. Fun fact, like any mode of communication, there is a sender and a receiver. Here, audio system works in similar fashion too. There's an inbuilt audio source component that acts as a sender or transmitter, and there's an audio listener that is attached to our main camera by default when a new scene is created.